How's it going, everyone? My name is Ryan and I'm a part of the Teen Advisory Board at the Howard County Library System. Today, I'm going to go over probability and what it really means. Let's get started. So what is probability? Probability is basically just the chance or likelihood that something will happen. You can calculate it by doing the amount of wanted outcomes over the amount of total outcomes in that scenario. And this percentage lies between 0 and 100%, or in terms of just regular numbers, 0 and 1. As you can see here on the scale, 0 would be impossible, while 1 means certain. It will definitely happen no matter what happens in the situation. That outcome will always happen. Let's see an example. Right now, we have a coin flip, one of the most basic forms of probability. We can describe this in two ways, one of them being heads, if we were to flip it, and the other option being tails. These are our two options of acquiring while we're flipping the coin. So how do we calculate what's the probability of getting one over the other? Well, since we have two options, we can describe each one as something over 2, since there's two outcomes in this situation. Since heads is one of the outcomes of the situation and tails is the other, we can describe that as just 1 and 1. So each one, therefore, has a probability of about 0.5, 1/2, or 50%. Same goes with tails. Now, what does this mean? As you can see, 50% you'd think it means half the time it'd be heads, half the time it'd be tails. That means for each one, there'd be an equal amount of heads and tails per every even number of flipping the coin. But if we were to try this in real life, you may not always find it to be 50% all the time. Let's say, for instance, you're flipping it 10 times. Maybe 8 of the 10 times is heads and the other 2 are tails. Now, that's obviously not 50%. It's a lot more heads than tails. But how did this happen? Well, we describe this as theoretical versus experimental. Theoretical probability being the 50% that we just acquired. That one is thinking in the situational sense, where we have two options, and to exhaust those two options, we have one heads and one tails, and therefore it has to be 50% in the long run. However, experimental means actually doing the situation, such as flipping the coin each time, and you're getting a number of heads and tails that may not always match up with the 50%. Now, this has to do with the amount of times you actually run the test. Let's say we did 10 tests, for instance. As you can see in the first graph in the top left-hand corner, the amount of deviation is drastic, and it's not always half the entire time. Sometimes it is exactly 0.5, sometimes it's a bit up and it's a bit lower. But as we take more tests, for instance, in the next graph on the right of that, that has 50 numbers of flips, but it's getting a bit closer to that 0.5 or 1/2 probability. And if we go even more, such as 100 flips, you see the line getting even closer to 0.5, whereas when we go to 1,000, you can see it's almost exactly 0.5, showing that depending on the amount of trials you do, you get a better and more exact answer and a closer answer to your theoretical. So let's talk about another common example, a bag of marbles. Let's say we have 5 red marbles, 2 blue marbles, and 8 green marbles in a bag. What's the probability of choosing, let's say, 5 red marbles in this case? We have 5 red marbles, 2 blue marbles, and 8 green marbles. In total, that would give us 15 marbles in the bag. So that's the amount of options that we have in total. Now, to represent the amount of marbles in this bag, we can just take the 5 marbles that are red out of the total 15 that are containing blue, green, and red. This would give us a simplification of 1/3, and as a percentage or as a number, we can write it as 0.33 or 33%. And so that means 33% of the time you'd be getting a red marble if you were to randomly pick a marble out of the bag. Now let's take a different situation, for instance. Let's say that you want to take either a blue or a green marble, and you'd be fine with either one. So we can take 2 being the blue marbles plus 8 being the green marbles to equal 10 options that you're allowed to choose from. If we were to represent this in the form of total, we could just do 10 over 15, which is 10 marbles that you're allowed to choose from over the amount of total marbles in the bag. This can be simplified into 2 over 3, or 0.66, or just 66%. So that means 66% of the time, you'd be getting either a blue or a green marble as you randomly pick one from the bag. But what if we wanted to calculate what the probability would be if we were to pick something and another one right afterwards? This is what compound probability is. This is used if a previous requirement must be met in order to proceed with the actual experiment. For instance, we have here heads and tails. Now, if we were to toss a quarter, a dime, and a nickel, what's the probability of getting all three tails each time? We see in the first one, a quarter, that has a probability of getting 50% heads or tails. But then as we go on to dime, once you get one of those heads or tails, you must move on to another set of probability of heads or tails. And then once you do that, you have another one to go through with the nickel. Proceeding with all these tests, you have many different results to choose from. As we can see here, if we got tails, we would be going down this path, having another choice of heads or tails. We can take tails again, and then right after that, the nickel, we can do heads and tails again, and then we get tails again, and then we get this answer right here. Now, this is the favorable outcome of the total. How many are there in total? Well, we have 1, 2, 3, 4, 5, 6, 7, 8. That means that the probability of getting all three tails of all three coins is 1/8, being one of the options out of the 8 choices. Now, how is this calculated? You can just calculate this in an easy manner through multiplication. We have 1/2 being the first probability of getting a heads or tails with the quarter. Next up, you have another half. So you multiply the first 1/2 by the second one to get 1/4. As you can see here, we have 4 options. But we have another coin. So to get that one, we must multiply yet another half. And as you can see here, this results in 1/8. 8 being the total amount of heads and tails options that we have. And as you can see here, that is 8 in total. Let's move on to another common example, the spinner, in which we have 4 different colors, all of which you have the same chance of getting each one depending on how big their sizes are. We have 7 parts of red, 8 parts of green, 3 parts of purple, and 5 parts of blue. Let's do an example like we've seen before. What is the chance of getting, let's say, red on this graph? Well, since we have 7 of red, we can take 7 parts of that red over the total amount, which is 7 plus 8 plus 3 plus 5. That gives us 7 parts of red over our entire total in the spinner being 23. And that would be our probability of getting red on this if we did one spin. But let's say right after getting red, we want to get a blue color. So we can describe red, as we mentioned before, as 7 over 23 being the whole. But to mention blue, we'd have to do 5, being 5 blue parts, over the total 23 again. So let's envision this. We just got a red, and that's a 7 out of 23 probability. And now, right after that, we want to get a blue. And so using the method as we did before, we'll just multiply these two together, giving us 7 over 23 times 5, being the blue, over another 23. This gives us the probability of getting a red and then blue right after getting that red, giving us 35 over 529. And that would be our probability for getting red and blue consecutively. Remember, this is different from our previous example, where if we wanted to get a red, 7 over 23, or a blue, then we would do 7 over 23 plus 5 over that other 23, giving us 12 over 23. This answer represents the probability of getting a red or a blue from the spinner, whereas this probability right here, 35 over 529, gives us the probability of getting red and then immediately after getting a blue. Thanks for listening. I hope you enjoyed this video and you were able to learn something. See if you can try this in the real world. There's so many cases that you can use this in, and I bet it'd be fun for you to test. See you later.